There we go. Okay. Also, before I forget, because I forgot before, share my screen, do the whole thing. There we go. Let me just screen this. Sorry. There we go. All right, so welcome to the November 4th, 2021 Women in Computer Science and Engineering Club meeting. So some club news is, thanks to Oz, we have our weekly one newsletter for November. This time is provided both through Discord and email, so please feel to check that out. For IEEE news, for any like jobs or initiatives that we found, for like weekly puzzles and things like that, a whole bunch of other stuff. Next week, there'll be no general meeting because it's a holiday and campus will be closed. So yay. So it's not a whole lot of news, but any questions? That was totally fine. So it means that we can get straight into today's workshop. It is an intro to Python class. So what is Python? It's an interpreted, object-oriented, high-level programming language with dynamic semantics, sorry. So to explain it more simply, it's a very general purpose language. It's simple, it's easy to learn syntax, and it supports modules and packages just like how other languages support like libraries and things like that. There's a lot of extra stuff that you can add on to increase all the cool and crazy things you can do with Python. And then that will be for later if we can get to it. So let me close that down real quick, move over to my IDE here. I don't know if you want to like program along at all. I do have some online interpreters. Otherwise, if you just want to watch, that's perfectly fine too. I did post some in the Discord chat. So if you don't have like an IDE or something like that you can use for Python, then at least there's some online stuff. But the one I'm using is called PyCharm. It's free to use. I don't know if it only does Python, but it's great. I've been really happy with it. So the first thing that I want to cover in Python is basic output. If I can spell, my goodness. There we go. So some basic output. So Python is super easy to output things to the console. All you need is keyword print. And then you're in parentheses, whatever you want to print. In this case, maybe you want to say like hello. That's all I need to do. It's just the keyword, print, and then whatever that I want to print on the inside in quotations. And just to show you that it works, let me run it real quick. And there you can see it displayed hello. So super easy to display output, but it's not a whole lot like fancy stuff you can do quite yet. It's very simple. Let's go into the next kind of really important thing is variables and data types. Next really important concept, really just any programming language. So variables are containers for storing any kind of data value. There's three basic ones for Python. There's numbers, there's strings, and there's booleans. And like, unlike other languages like C++, where it's really rigid, you have to declare it as an int or as a string or as a float, double, or whatever. Python just kind of figures it out. You just name it and you give it its value. You don't have to say like this is a number or this is a string. Like for example, I want to have a variable that holds a name. I can just say name is equal to say like Alex. And Python is able to figure out automatically, oh, that's a string. It's a variable that holds a string. Same with numbers, really easy. Like maybe I want to put like age, and I can say age is just 24. And Python's able to figure out, okay, cool, that's a number. It knows that's a number. Same with if you were to do like decimals, so if you have like floating point number and things like that. Same with Boolean, you don't have to like declare it. So I'm going to put it like is male is equal to true. And for Python, Boolean values are uppercase, so capital T for true, capital F for false. So some basic variables. One I really want to go over, it's a really important type of data type, is strings. There's a whole bunch of stuff that you can do with them. So the next thing we'll do is working with strings. So one thing to note with Python is that when you print something out, it automatically jumps to the new line. So like, for example, with C++, it doesn't automatically, so you have to do like the end line or the escape character /n. But Python's nice, it just does it automatically. So to show you that, I'm going to do print, like this is my first Python program. I'm going to do another print statement. I'm going to say Python is fun. My goodness, I cannot spell. My goodness. There we go. So I'm going to run it. So we still have our hello from earlier, but we have our string. Sorry, no, it is a string, but we're outputting. This is my first Python program, and then automatically it jumps to the new line when we print another print statement. But we can also like almost like force tell it to when to skip a new line. So we do have some control of when it does and doesn't. So for example, we could do like print, I'll say this is my first line. And then you can use an escape character, which is this \n. And then whatever you want to do on the next line. So I'm going to say this is second line. So I'll put this just to show you that that works. So there you go. It's a single line, single print statement. But because I use this escape character, it tells Python that I want whatever is after it to be on a new line. Moving on with strings, you can combine multiple strings together. So let's say we have a phrase, it's going to be equal to CSUSB. And say that we want to add something to this phrase, to this string. You can use something called concatenation, which is just this little plus. So how you do that? And then you do my phrase equals what my phrase currently is, which is CSUSB, plus whatever else you want to add on to that, our current phrase, that CSUSB. So I'm going to say is my school. And then just so that we can see what it did, I'm going to print our phrase here. Actually, I should probably, I'll just do it before and then I'll do the after. So before we just had CSUSB, and then we concatenated is my school onto the back of it. So when we print, it should show that. Yeah, there we go. So the first time when our phrase was just CSUSB, and then we added another string onto it to make one whole string, CSUSB is my school. There's a whole bunch of like useful functions that you can use along with strings, which is really, really great. They're functions provided by Python. So, for example, you can make things into uppercase letters or lowercase. So, to make things simple and so that we can see what's going on, I'm going to be putting most things in print statements, but know that on your own, you don't have to always do this. So, say if you want to just like change your phrase to uppercase, you don't need to have the print statement. I'm just going to have it there just so it's going to print the console so we can see what's going on. So for example, if I wanted to change our phrase to like all uppercase, I can do that. It's just my variable name is phrase. I'm going to do dot lower than the open and close parentheses. Again, to do this, you don't need that print. You totally could just do this. It'll do the same thing. It'll just be doing that in the background. But you won't be able to see it because I haven't printed it to console or anything like that. So I'm just using this print statement just so we can see what is it doing. But it's not necessarily to actually be able to use these functions. So let's see here. Another one you can do, since we can do lowercase. Or did I say I was going to do upper? I think I did upper and I did lower. That's okay. So we can do lower. And we can also do upper. So phrase dot upper. open close parentheses. And so let me run it to show you that works. There we go. So our phrase originally was at CSUSB. We added is my school. Then I converted it all to lowercase. And then I converted it all to uppercase. Really nice little functions that come with Python that do this stuff for us. There's also a whole bunch of other stuff that you can do. You can test if something is uppercase or not. Before I do that though, this just sets it to uppercase, but it doesn't actually like manipulate the string itself. So I'm gonna make sure that our phrase here is gonna be actually set to uppercase. So our phrase now is uppercase. It's not just like displaying it as it is, like it is here. Our phrase now will be set to all uppercase. And then I want to see, is it uppercase? You can use a function called isUpper, just like that. So I'm going to print it out just so we can see what's going on. So I'm going to do phrase isUpper and open close parentheses. So it should, if I run it, it should say true. There we go. It looked at our phrase. Our phrase with the CSUSB is by school. It's all in caps. We want to see, is it all in caps? So we use that is upper, and it returns true because it is in uppercase. The opposite is true with lowercase. They want to check, is it in lowercase? You can do phrase dot is lower, open close parentheses. So let me run that. There we go. So that this bottom line here is what the new thing that we added is we're checking, is it lowercase? It returns false because our phrase here, the CSUSB is my school, is in uppercases. So it's going to say false, it's not in lowercase. All right. So let's move on to just a couple more things I want to go over with strings. You can find the length of a string using the length or just len function. Basically, it's just you do whatever is in the parentheses, whatever you want to find the length of. So our variable is phrase, holding our phrase, CSUSB is my school, and I want to find the length of it, aka how many characters does it have. So I just use that length, but I want to print it out to console so we can actually see what is that length. Let it run, and there you go, it returns 18. Our phrase here, CSUSB is my school, is 18 characters long. So it could be really useful, especially if you need to iterate through a string. You can use that that length function for it. It's how long it's how many characters. And I believe it includes spaces. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So every character, the letters and the spaces, it just counts how many are in here. And it has an 8. Okay, could be really useful if you need to go over, like iterate through a string. It's really good for that. So you know how long it is. So you know when to stop iterating over it. But we'll get to an example hopefully later on that will use that. So that's just find the length of it, but we can also like grab a specific character in our string. So maybe I want to get that like capital C from CSUSB. What you can do is that you use our variable name here, which we have phrase. We use these brackets, and what's in them is you put a thing called an index. In this case, I'm going to put 0. So in our string, each character is given an index. It starts from 0 and increments by 1. So like CSUSB, C would be index 0, S would be index 1, U would be index 2, S would be index 3, and B would be index 4. So say if we wanted to just get that C from CSUSB, it's in that 0 index position. So I put a 0 in those brackets. So let me run it just to show you that it did get our C. So there it is. We grabbed that C, that very first character from our phrase. which is great again because you could do tons of stuff with it. If you want to change it to something or just want to grab something from a string, you can do that. Also, say like you have a phrase and you want to find like where is something located within the string, you can do that. So I'm going to still have our phrase here. Maybe I want to find where like the a B is in this. So it's phrase.index, and in the parentheses, maybe, and I want to find that B. I want to find, okay, where is it in my string? So let me run it real quick. And it returns the index 4. And to kind of like show why that is, and the C, index 0, S1, U2, S3, and B is an index 4. So it returns that 4, saying that that B that you're looking for, it's an index 4. You can also replace certain things in a string using a replace function. So here I'm going to access our phrase. I'm going to use the function replace. And what goes first in parentheses is what you want to like, what you want to replace. So say I want to replace my with a, so I'll say CSUSB is a school instead of CSUSB is my school. So I'm going to tell it right now, if you remember, we set it to all uppercase. So I have to make sure that I say I want to replace the capital M, capital Y. And I want to replace that with a capital A. And I'm just going to print the results of that so you can see that it did do the replacement. And there we go. So we have our phrase, but we replace the my with a. And then let's see here. I think that's pretty much about it. There's a whole bunch of other things you can do with strings, but this is kind of like some basic fundamental stuff you can do. And then let's see here. I think since our output's getting kind of busy here, I'm going to comment out all of this so it doesn't get in the way. So comments that I've kind of been doing passively, I haven't really explained. In Python, for a single line, it is this pound symbol and then whatever you want to put for your comment. If it's a block, like multiple lines of comment, so you use 3 of these quotation marks at the top and at the bottom, and then whatever you want in between. And then all these comments will just be ignored by the interpreter so that you can make it human friendly to read and understand what's going on, but the computer doesn't need to know what it is. It's just for us. And so yeah, that's basically just how you do comments in Python. It's really easy. So the next I want to do is working with numbers. Hello. Club meeting.
Oh.
This is the Women in Computer Science and Engineering.
Oh, okay. Okay, if you guys need anything, my name is Dr. Tajani, so I just wanted to introduce myself.
Yeah.
Great, great. If you need anything, just let me know.
Sounds good.
Thank you. Thank you.
All right, so we're going to work with numbers. Now, since we've done strings, let's do numbers, the other data type within Python. You could do a whole bunch of things. Computers are great at math. You can do basic arithmetic and have all different types of numbers as well, not just integers. It could be negative numbers. You can have decimals, things like that. So I do very, very basic. Just show you numbers. I can just print and then say it's a 2. It's going to print 2 to the console. There's our 2 right there. We can also do decimals, aka floating point values. Let's do like 2.0987 or something like that. That Python's totally fine with that too. We're just going to output to our console. And there it is. And what's nice about Python is you don't have to tell it what this is. It just kind of figures out, oh, this is an integer and this is a float. Whereas like for in C++, you'd have to say int and then like the variable name and then what it is, or float. But Python's nice. You don't have to tell it that. It just kind of figures it out.
floaters.
Yeah, you don't have to specify, since it's able to kind of just figure it out by itself. Like an example, if for like C++, you'd have to like float, I don't know, num is equal to like 4.5. You'd have to very explicitly tell it it's a floating point number. But in Python, I could just say num is equal to 4.5, and it's perfectly fine with that. It knows, okay, yeah, cool, that's a float. Same with, even if I wanted to like change it, I could say num is equal to 2. I could change that 4.5 to a 2, and Python's totally fine with it. So it's kind of nice, but also maybe kind of annoying with Python is that it's so flexible. But then you go back to some of the more rigid programming languages, and it's just kind of bizarre sometimes. But it all depends what you're using it for. Like for my intro to AI class, this is great. It'd be so annoying to do since it's useful plus. But there's, depending on what you're trying to do, different languages are better for different things. But you can also do negative numbers. So I'm going to say like -2. Start with that. You see -2. And we do a whole bunch of arithmetic, addition, subtraction, all that stuff. So like, I don't know, 2 + 4. Then we're going to do like 2 - 4. And then we like 2 × 4, which to multiply, you just use a little slow like star character. And then to divide is just 2, and then this /4. And I'm just telling it to print all these values. There you go. Or 2 + 4 is that 6. 2 - 4, -2. 2 × 4, 8, and then 2 divided by 4 is 0.5. And you don't even need this in a print statement. You could totally just do 2 divided by 4. Python's really nice. I'm just having the print statement just so I can see what's going on. Let's see here. So as I'm inputting the numbers as they are, Python will see it as a number. But say maybe I want to convert that number to a string. You can do that using this str method. And I'm just gonna I'm gonna have a number. I'm gonna say num is equal to 5. And I'm gonna turn that number, it's a 5, it sees it as a number, but I want to turn it to a string. So I'm gonna put string, and in the parentheses, I'm gonna just put num. And so it's gonna convert this 5 into a string 5, aka like a text character rather than an actual number. And let's see here. So it depends on what situation you're in. Just it's kind of nice you can do that in Python. You can convert data types. Another, let's see here. Another thing you can do with Python is there's like a bunch of different like math functions that you can do. Like for example, like absolute power, square root, maximum value, minimum value, stuff like that. So let's do an absolute value. So I'm going to set my num is equal to -5. I want to find the absolute value of that. So I use ABS, and in that ABS, I'll put my variable, my num, that holds my -5. I will run it. There you go. You can see my -5 has now been turned into a +5. It took the absolute value. Another one you can do is you can find something to the power of something. So the function that you use for that is POW for power. And there's 2 things that go in our parentheses. The first thing is the base. So maybe I want 5 to the power 2. So 5 squared. That's how it is. First thing is the base. Second thing is the exponent. Right, another way, this is the same as 5 to the second power. So I'll print that out just to show you it should be 25. Here we go. Found the second power of 5. We can also find between 2 numbers which one is the maximum. I'm going to do max between 5 and 2. They can also do minimum as well. So min 5 and 2. Let me run that real quick. So this first line here after 25, I was asking for what's the max between my 5 and 2, and it returns my 5 because 5 is bigger than 2. The last line here, this 2, it's returning a 2 because I asked for the minimum between a 5 and 2, and 2 is less than 5, so it will return that 2. You can also round values using a method called round. So just type out round, and what you want to round, you put in these parentheses. So maybe I want to round like 3.2. It follows standard rounding rules. So if it's like 0.5 or higher, it rounds it up, or anything lower than 0.5, it'll round down. So like this 3.2, it should round it down to 3. But there you go. The 3.2 has been rounded down to just 3. So there's some kind of basic functions that come along with Python when it comes to doing stuff with math. But what's nice is, like a bunch of other programming languages like C++, they have libraries, things like that, is we can import modules into Python. So like one of them is a math module that gives us a whole bunch of other functionalities. And how it works is, I'm just gonna put it up here. It's kind of good practice to put it at the top so it doesn't get mixed in with all your code. What it is the keyword from, and then it is the, I always keep wanting to call it a library. But the, I guess I can use that. The library that you want to choose from. This one is called math. And then you use import. And after this import here, there's certain functions that you can just import directly. Like if you know there's only one that you need, then you could just import that, versus you could import the entire library. But it's totally up to you. To be more efficient, you technically only import what you need. But for now, to make it easy, I'm just going to import the entire thing. And so to do that, I just do this star character. So it's going to import, and we can use everything within that math library. Say, for example, though, I wanted to have something very specific, though. I only wanted to get like one thing from math. There's a function called floor. So I'm going to do from math import floor. It's highlighted out because I already have this. But just an example, say I don't need the entirety of the math library. I only need that floor function. So I can import just that floor function. But for now, I'll just keep it. We're just going to import the entire library. Then let me comment some stuff out because it's getting a little cluttered. There. And do it there. Okay. So some of these functions that we get from that math library are ones like floor, ceiling, square root. There's a whole bunch of other ones, but those are kind of like some basic ones I wanted to go over. So say we wanted to find the floor. What it is it basically it's going to round a number down no matter what. So for example, you have like 3.7. If you're following standard rounding rules, it should round up to 4. But with that floor function here, it's going to round it down no matter what. It'll round it down to 3. So I'll run it just to show that. There it is. There's that 3. Likewise, instead of floor, you have ceiling. And then whatever you put in the parentheses is whatever you want to round up no matter what. So maybe you have like 3.2. Standard rounding rules, 3.2 could be rounded down to 3. But because we have the ceiling function here, it's going to round it up to 4 no matter what. So let me demonstrate that. There it is. There's our 4. Another one is square root, which you use the SQRT keyword. And then the parentheses, whatever you want to take the square root of. I'm going to do like 36. And the square root of 36 should be 6. There it is. So that's some basic stuff that you can do with numbers within Python. Again, there's so many other things you can do, especially with that math library that you include. There's tons of other things, but you can't include all of it, unfortunately. But there's lots and lots of documentation online if you're more curious about like all the different things that you can do. So now that we've talked about variables, we've talked about printing them to the console, we've talked about manipulating them like strings, manipulating numbers and things like that. We want to, I can show you a way to like a little more fancier way to output stuff. Because right now we just have strings, but let's say if you want to output something like name, that's a number or something like that, or their age, or if they're, I don't know, say if they're male or they're not male or whatever. Because right now, the only thing we've gone over is just printing a string. We had that print hello. Or we have here, it's like printing out like the number, but say we want to have a mix of things. How you do that is if you've ever learned the language C before, Python borrows from it for its print statements. So real quick, I'm going to borrow our variables up here. We have our name, we have our age, and we have Ismail. And so I want to print out, say, my name is, and I don't want to hard code it because say I want to change this name. If I hard code it like this, I have to go back into the code every single time and change it. So it's why I'm going to use a variable. It's going to be a placeholder for whatever name we want it to be. So hi, my name is. And what you do is the value that you want to like print in that space, we want to print our name. It's a string. So we're going to do this, the parentheses, not parentheses, sorry, percent, and then S. So this is letting Python know that a string should go here. Kind of a placeholder basically for a string. And that's all I want to do is I want to say my name is Alex. And so now that we have our placeholder, the string's going to go here. We need to tell Python what is that string going to be. You use this parentheses, and I want whatever my name is to go in this spot right here. So for now, I have my name is equal to Alex, so it should insert this, my name is Alex. Specifically should insert the name Alex into this spot. Let me show it real quick. There we go. It says my name is Alex. Same I wanted to change it. I could do like Daniel. So that's all I did is change my variable value. I don't have to touch my print statement because my variable here, its name, it's holding that value. And it's just going to output whatever I have held in name. All right, so say then maybe you want to print out like a number instead or a Boolean. So I'm going to say like print I am, and I want to find how old am I. So like we did before, this was a placeholder for a string. We're going to do a placeholder for a number, specifically decimal value. So I do this percentage %D. It's a placeholder for our number. And then years old. So we have our string set up, but we have to tell Python, okay, what's going to go in this decimal placeholder. Put in my percent, and then I put age. So whatever my age is holding, the value that that variable is holding, is going to be put where that percentage %D is. Run that real quick, and there you go. Our age was 24, so insert that 24 into that little placeholder here. So I am 24 years old. The last thing is say you maybe want to like output like a Boolean. You can do that. So I'm going to say am I male? And then after that, I'm going to want to put like either yes or no. So it's going to output as a string. And what string I want to output is the one returned by our Boolean. So is male. So let me output it. There you go. It's asking, am I male? My is male set to true. So it's going to output true. So that's kind of the basics of, so let's say outputting more than just strings. You're outputting like other data types along with strings. Right now I have it where you're just outputting one data type along with your string, but say you have like multiple like numbers and stuff like that that you want to output in a string. So I'll say like print. I'll combine what we have pretty much is I'll have my name is, we want a placeholder for a name. It's going to be a string. So I'm going to do that little %S. And I am, we want a number. So I'm going to put that %D. Years old. So we have our string set up, but now we just need to tell Python, okay, what is going to be in those placeholders? Use that %. And because we have multiple variables we're going to use here, you have to put them in parentheses and make sure that they're in order. We have our name first, and then we have our age second. So I'm going to put name and then age. Output that, and there we go. So my name is Daniel, and I am 24 years old. So maybe a little cumbersome compared to some other languages, but this is kind of the, I guess, fundamental way that Python outputs multiple data types, strings with numbers, strings with booleans, or whatever you want to have. So now we know how to do fancier stuff with the output. Let's get some user input. So let's see, user. So how Python works is you use a keyword called input. And then within that input, you just say a prompt. So maybe I could say like, what is your name? But our input function here needs to set something, our name, whatever we're going to input, to a variable. So I'm going to just reuse that name variable that we have. So name is going to be whatever the user inputs when they're prompted with what is your name. So I'm going to demonstrate that. I'm going to use what we just learned about output. So I'm going to say your name is, I want to output your name, which is a string. So I'm going to use that %s and say that we want to output the name. So I'm going to run it. So it's asking me, what is my name? I'm going to put down Alyssa. And then press enter. What I entered Alyssa was then set and saved in our variable here called name. And then I just printed out your name is, and then whatever was set or being held in our name variable, which was Alyssa, which we got from the user. By default, everything that you get as input for Python is strings, which, again, depending on what you're doing or what other language you're used to, is kind of annoying. Like for me, coming from C++, that's a little bit of annoying that everything comes in the terms of strings, so you have to sometimes be careful. Like say you're getting a number from someone. You have to be careful. If you're going to do math with it, you have to convert it to an integer. Because otherwise, if you keep it as a string, it's going to be confused because it's seen as a character and not a number. So to get something like as, say, as a actual number instead of just a string, I'm going to get like your age. I'm going to say age is equal to, you still need that input. I'm going to say, what is your age? Ask them that. But outside of this input, I'm going to use int. And within that int is our input, and then what is your name? So what it's going to do is this input part is going to get whatever the user types in their keyboard. And then the int part is going to convert that, which is a string by default, into an integer. And just to display that it did get our age correctly, I'm just going to output it. So you are years old, and I want to use my age. I'll print that out. And it's asking me for a name, and was my age, and put 23. There you go. You are 23 years old. And now this value, this 23, is an integer. It's a number value. It's not a string. So if I want to do math with it, then I totally could. Whereas if it's a string and I try to do math with it, I'd run into issues. So it's basic input, outputs, data types, and things like that. So now we can get into some of the more fun stuff. Now we have some of the fundamentals. So within Python, there are, let's see here. I can think of about 3 data types that are super, super useful. And what these data structures are is they help us like keep track of data like in an organized, easy manner. So far we have variables, they just hold one value. So like name, it only holds this one value, whatever I set it to. Like I can't set it to like a bunch of things. But if I want to do something like that, I want to keep my data like all organized and contained within something, I can use a data type. And the 3 that Python has, at least the main ones that I mostly use, are lists, tuples, and dictionaries. So I'll start with the most basic, which is lists, which are used for so many different things. So lists just hold multiple items in a single variable. They're basically the same as like arrays in other languages. The syntax that you use is just a name. So I'm going to just say friends. That's the name of our list. Then you use these brackets, I think not braces, brackets. And then within that, then you just list what your items are going to be in your list. So my friends, I'm going to put one is Alex, comma. The next one's David, comma. Next one's Daniel, comma, and then Mary. So I have now 4 objects, Alex, David, Daniel, and Mary, all contained within one variable, which is our friends, which is a list. So I have 4 elements in this list. Very, very simple. The nice thing about Python, again, because it's kind of simple and really loose, I guess you can say, is unlike, say, like C++, if you have an array, it can only hold one data type. Python doesn't care. You can throw whatever you want in it. So, like, I'm going to say example list. You can throw in a number. You can put in a Boolean. You can put in a name, a string. And Python is totally fine with that. Other languages, you can't do this. It get all mad at you. But the Python, you can throw whatever you want in a list. It's perfectly fine with it. For this case, I'm just going to keep it. We just have a bunch of strings. But just to know, you can do this. So we have our list set up. I'm going to output it so you can see that it does indeed have all of these values. So I'm just going to put, print friends. There we go. It prints out our list and all the elements in it. But that's outputting the entire list. Say if we want to access only certain elements of it, you use kind of like what we did for the getting certain characters from a string. We use the same format like indexing. So what I want to do is maybe I want to get my first friend. I want to get Alex. I would do friends, the brackets, and then 0. Because Alex is in the 0 index. So to go back, friends, Alex is in the 0 spot, David's in the 1 spot, Daniel's in the 2 spot, and Mary's in the 3 spot. So if I want to get access to Alex, I need to put in a 0 because it's at the 0 index. So friend 0, but so we can actually see what this is. I want to print it. And it should return just Alex. Yep, there we go. So it's accessing just one item in a list. So maybe say also then maybe I want to access Mary, the fourth item in our list. So I'm going to put print friends, and she's at index 3. So output, and there you go. You see that we grabbed the whatever was at our 3rd index, aka the 4th item in our list, which was Mary. So that's kind of accessing a list from forwards from 0 to 1 to 2 to then 3. But you can also access a list backwards by using negative numbers. So for example, what if I wanted to start at the back? I wanted to grab Mary first. I could totally do what I just did. I could do this 3 here, but I could also use negative numbers. So say maybe I want to do if I do -1, that'll still access Mary. So let me output it. So I'll show you. There we go. We grab Mary 2 different ways. Kind of a forwards method with that 3, and then kind of a backwards method with that -1. All right. So that's just printing one element. We can also print a range of elements. For example, let's say I wanted to skip Alex, and I just want to print everything else after him. So I'm going to do my friends, and we use those braces. And then what I'm first going to put in is my starting index. So I want it to start printing at index 1. And maybe say I want to stop printing at index 3 then. So it'll start from David at index 1 and should go all the way up to Mary, but it'll be skipping Alex. Since I'm not including my 0 index, I'm just starting from index 1. Let me spell correctly. So I'll show you. Oh, I did forget. I'm sorry. That is one thing. Even I forget it sometimes. So Python, whenever you have a range, the upper limit is never included. So when I say I want to range from 1 to 3, it's only going to give me 1 and 2. that 3 is non-inclusive. So like for math, if you've ever seen it, it'll be like that brace 1, comma, and then it'd be parentheses 3, if you've ever seen that format before, where 1 is included, but 3 is not. And kind of annoying. So like say maybe if I do want to get all of them from David to Mary, I would need to make sure I do 4. 4 is not included, so it'll do index 1, 2, and 3. And there we go. We got David, Daniel, and Mary. Now let's see, maybe you don't know the length of your list, maybe you don't like know where the stopping point is, or you only want to get like start from 1 and then get all the rest. You can do that with like this. You still have your friends, your brackets here, and then maybe I want to start from like index 2 and I want to print everything after that. You just use this colon and then nothing after it, so it knows to start at index 2 and print everything after that. So there we go. My index 2, Daniel's at index 2, and it's going to print whatever the rest is there, which Mary's the only other one in the list. So that's just kind of like accessing different elements of the list. But say maybe you want to like modify an element, you can do that using this indexing. So maybe like David's no longer my friend, and maybe Josh is my friend instead. So David is in index 1. So I'm going to access that value at index 1 within our friends. I'm going to set it to something else. I'm going to set it to Josh instead. And I'll print our friends here just to show you that David should be replaced with Josh. And there we go. We have our Alex, Josh, Daniel, Mary. David's no longer there. Josh replaced him. So it's kind of the fundamentals of like accessing and maybe, but yeah, sorry, a bit of manipulating lists. But there's still a whole bunch of other functions and crazy stuff you can do with lists. Tons of stuff that you can do. So for now, I think I'm going to keep this friends list, but the rest I'm going to comment out just so it doesn't get in the way. And I'm going to do a lucky numbers list. So lucky numbers. And then just to kind of call attention to it, the format that I'm using here, if you have like multiple words in a variable, you don't have to do it like this. Like you can have it all one, lucky numbers, do like camel face where it's like capital N. For me, I just personally like to do this little underscore. Just if you're wondering why I have, whenever I have 2 like words in a variable, I always, it's just kind of common practice. So I like to just put that underscore, but you don't have to. So we have lucky numbers. I'm going to say we have like 3, 27, 33, 40, and maybe like 777. So that's my list of lucky numbers. So maybe like you have 2 lists and you want to combine them together. You can totally do that very easily in Python with the extend function. So maybe I want to add like the lucky numbers onto the back of friends. So as long as I spell correctly, my friends, I'm going to use the function .append. And the parentheses is what list I want to add onto the back of friends. In this case, I want to add my lucky numbers onto the back of friends. So let me print my friends list just to show you that we do modify it. There we go. Now you can see we still have, you know, our Alex, David, Daniel, Mary, and all that stuff. But the last element on our list is we put in our list that lucky numbers. Oh, I'm sorry, I'm doing append. This is adding an element to it. I can go over that too, sorry. Extend is actually combining them. Let me show you that real quick, and then I'll show you the append. So I get them confused. There we go. So it's actually combining the list together. So now 3 is its own element. 27 is its own element, 33, 40, 777. Those are all its own element within my friends list. I just basically combined my 2 lists, but I saved it in my friends list. Now what I accidentally did is the append is say you want to add something to a list. I'm going to do my lucky numbers dot append. maybe I have like a new lucky number, like, I don't know, 44. I just do append and then what I want to add, which is 44. And I'm going to print my lucky numbers. So yeah, there you go. There's that 44 that's been added onto the back of that list. All right, so let's see, some other stuff you can do is instead of maybe like replacing something, you could like insert something in if you want. So maybe I want to insert a lucky number at a certain spot. So maybe I'll do my lucky numbers. You do dot insert. Then the first item in this parentheses is where you want to insert. Maybe I want to do insert at index 1. And the next is what I want to insert. And maybe I'll do like 65. I want to insert 65 at index 1 of my lucky numbers. So let me print out my lucky numbers to show that. There you go. So the nice thing about insert is it doesn't replace anything. It keeps all that you have. It just, as it says, inserts it in a certain part of your list. Like 27 up here was at index 1, but we wanted to insert 65 there instead. So you can see we inserted 65 at index 1, and everything else just gets pushed behind it. We can also remove things from lists. So maybe 65 is no longer a lucky number. So I use lucky numbers dot remove. And I have to specify what do I want to remove. So I'm going to remove that 65. And then I'm going to print my lucky numbers again. So there we go. This line is when we inserted it, but then I removed it. And now we have a list that no longer has that 65. We can also, if we want to, completely clear a list. We want to completely empty it out. So maybe for like my friends list, I don't have any friends or something. So I can do friends dot clear. And then let me print the friends so you can see that it did indeed completely empty out that list. There you go. At the bottom here, that is an empty list. There's nothing in my friends list anymore because I used that clear function. So another function that you can do is say you want to remove something just off the back of your list here. So my lucky numbers. Maybe I want to get rid of the very last one. So right now we have 44 as our last one. We want to just get rid of that. We use a function called pop. I'll print my lucky numbers. There we go. When I print it, there we go. We see now 777 is at the end. That 44 is no longer there because we popped it off the back. We can also, just like how we did with strings, you can find where is something located within a list. So maybe I want to like find where is, maybe like 33, where is it within my list here? Okay. So maybe I want to find, you do lucky numbers dot index. And then you put in what you're going to look for. I want to look for 33. I want to find what index is it at. So let me run it. And it returns a 2, which means that 33 is at index 2, which is correct. I look at my list here. 3 is at index 0, 27 at 1, and 33 at index 2. Then let's see here. Another function that you can do within Python is that it can count how many times something occurs within the list. So right now I have 1, 3 in our list. So maybe let me add another one. So I'm going to do lucky numbers dot append 3. So I'm going to add another 3. So I have 2 3s within our list. And say now we want to count how many 3s do we have in our list. So the way you do that is I'll do our lucky numbers list right here dot count. And in the parentheses is what do you want to count? And I want to count how many times 3 appears. So do that. It's going to output a 2 because right now we have 2 3s in our list. We had one 3, then we added 1 using this append, and we counted how many, and it gave us there were 2 3s. You can also sort lists, which is really nice. you can send them in ascending order. So maybe I wanted to have this list of numbers all in ascending order. Let's see here. I technically already have it in ascending order, so let me add something to it. Lucky numbers dot append. I'm going to add that 65 back just to show you my lucky numbers. So I added 65 on the back. It is not in alphabet, sorry, not alphabetical. It's not in ascending order. But say I want it in ascending order. So how you do that is I access my list here, lucky numbers, I do dot sort. And let me run that. Ooh, I did something wrong. What do you not like? Let me try. It might not like it because I'm printing it and sorting at the same time. Let me try that. There we go. Yeah, it just didn't like me printing at the same time that I was sorting it. So originally this was our out of order list here, but then I sorted it on an ascending order. So you go threes, then 27, 33, 40, 65, and 777. You also do the reverse order and descending order. In this case, you do lucky numbers dot reverse.
No, reverse print append. I'm sorry, I'm just repeating what you're saying.
Oh yeah,
So
good.
yeah, this set, is it based on a set of numbers that you've like array, like an array? Do you have to specify the array and the indexes, or is they already?
So what I'm doing right now, are you like asking like my lucky numbers? I'm guessing I have it as a list. It's just up further here. That is declared up here, and I just put a bunch of numbers in it. So that is my list. I don't have to say like how long it is. I don't have to say what like type of data is held into it. I just say this is the name of that list, and these are the items in my list. And then what I'm showing here is all the different functions that you can do on a list, like sorting it, inserting, removing, all that fun stuff. Does that hopefully answer your question?
Yeah, it just
If you're ever confused on anything, yeah, please feel free to ask me questions. But for now, I hope it's okay if I continue. That we showed you how to sort it, but I did misspeak a little bit. Reverse does not make it into descending order. It just reverses the order of whatever the list is currently. I have it in ascending order, so if I reverse it, then it should put it in descending order. So I use reverse on it. It was in ascending order, as we have here. I'm reversing it, and then I'm going to print it again. So there we go. Now you can see our list has been reversed. It was in ascending order, but then I reversed it, and now it's in descending order. And one last thing that we can do with lists, there's tons and tons of other stuff, but this is kind of some basic stuff, is we can copy a list. So maybe I want to copy my lucky numbers into a new list. I'm going to call it nums. So I'm just going to do lucky numbers dot copy. So it's going to copy whatever's in our lucky numbers list. And now nums is going to hold whatever is in lucky's numbers list. I'm going to print nums just to show you that. And there we go. This last thing we're putting here is our nums list. And I just copied what was in our lucky numbers list. Really easy, just with this copy function. So that's it for lists, at least just for now. Again, there's so much more you can do, but that's kind of the fundamentals. There's another important data structure within Python called a tuples, or it's a tuple or tuples for plural. So tuples are basically essentially like lists, except that they're immutable, meaning that you can't modify them. Like for lists, We could change stuff, we could remove stuff, add stuff. But tuples, once you have the data, you can't change it. Which is good. Like say if you have, I don't know, you like coordinates or something, and you don't want those coordinates to change, you can use a tuple so that those coordinates can't be modified. So I'm going to use that example, coordinates, and to say that it's a tuple, you use parentheses. So unlike if it's like a list, I use these braces, or sorry, no, brackets, but for tuples, you use parentheses. I'm going to have two items in my tuple named coordinates. I'm going to have 4, I'm going to have 5. So 4 being my first item, 5 being my second item in my tuple. And then I'm going to print my coordinates. Also, before I forget about it, we do kind of have a lot going on here, so I'm just going to comment out what we did on all of our lists, just so we can just focus on our tuple. I print it out. So I just printed out our coordinates tuple, and that's it. There it is. If we have 2 items in it, we have 4, and then we have 5. We can still access things within tuples, you just can't modify it. So maybe I want to print like the first thing within our coordinates tuple. So I'm going to access that by saying coordinates. And then remember indexing 4, the first item in our tuple is at index 0. 5, the second item in our tuple is at index 1. So say I want to get just whatever's is in this first index, the first place in our tuple. I'm going to put 0. And it should access that 4. There it is. It grabbed that 4 from our tuple. We just can't actually change, like say I want to change that 4, you can't do that with the tuple. So that's the whole point of it, is that once you have the data that you do, it's there. You can't modify it. So it's kind of basically like security almost, that you can think of it as built in. And that's kind of it. There's not a whole lot, because tuples again are kind of similar to a list, but just you can't modify the data. Another data type, extremely useful, are called dictionaries. If you've learned other programming languages, you might have seen these before. They're like key value pairs, or I think in like C++, I think they're called maps. So, oops, I need to fix that real quick. Here we go. Really, really easy and really useful data structure. So for here, to say that something is a dictionary, you're going to use these curly brackets. So I guess to review, we have our braces, means it's a list. If it was parentheses, then it was a tuple. And if it's our braces here, curly brackets, not braces, sorry, curly brackets, it is a dictionary. So I'm going to make a dictionary. I'm going to call it month conversions. That's the name of my dictionary. And now I need to put values in it. But to say that to Python, this is a dictionary, I'm going to use those curly brackets. So now I have a dictionary that's empty. I have nothing in it. But Python now knows, hey, my month's conversion, it's a dictionary. So how you structure data within a dictionary is you have some key, like that, colon, and then the value associated with that key. An example being, say you have January, the abbreviation for it, that's the key, and then the value for it is the full name, January. So that's one item in our dictionary. We can add more by doing a comma. And maybe then I want to do February. So my key will be Feb. And I want that key to correspond with the month's full name, February. Oops, that is one too many R's. There we go. Now I'll do me like one more, just to not waste our time with all of them, all the months. Let's say we'll do March. The key is MIR, and its value is March. And if it's the last item, you don't need to put a comma. Only between items do you need to have the commas. And then how I have it structured is totally my own preference. Like you could have this all in one line if you want to. You don't have to structure it in this way. I mean, if you wanted to, you could totally do this, where everything's all on one line. Like this. It still sees it as the same thing. It's just for my own preference, I like having like each key value pair on its own line. This makes it a little bit easier to read. Again, it's totally up to you, however you want to structure it. So that's setting up a dictionary. But now we want to know, like, what can we actually do with this? So as it implies, we have some key and then we have a value associated with it. What if we want to get the value at some key? So what I'm going to do is I'm going to access my dictionary. It's called month conversions. And how I access one of the values here is I use these braces and then I put in a key. Maybe I want to get the value associated with JAN. So that's my key that I'm giving my dictionary, and it's going to grab whatever the value is held at that key. So if I run it, it should print January. There it is. So that's using a key to access a value. You can also, another way you can do it, I don't really use this one, but I thought I'd include it, is you can also use a method called get of my month conversions dot get. And say again, I want the value held at JAN. I'm going to run it. And it also outputs January. They both do the same thing, there's just two different ways to do it. I personally like this one more, but if you want to, you can totally use .get as well. All right, so there are like kind of built-in error handling. So it's say like you want to get something, but it's an invalid key. Actually, that is one nice use of get. So let me go back. So I use the get and I give it an invalid key, like I don't know, cat or something. We have no key called cat here, so there's no value associated with cat. So if I run it, it'll still run, but it'll return none. Where I believe, just to test it, I believe with month conversions, if I do it this way and I put in cat, I think it'll toss an error instead. Let's see. Yep, okay. So doing it this way, giving it an invalid key, it throws an error, versus if you use .get, it just returns none. So it doesn't like throw an error. So I guess from a developer's perspective, maybe it is a bit better to do .get because your program's not going to crash because someone gave it an invalid key. But again, it's totally up to designer's choice what they want to do. But to further on with this .get, you can add like a default thing that it does once you get an invalid key. So maybe let's do this cat again. I'm going to just copy and paste. Let's say someone gives it cat, but if it's not a valid key, I want it to actually say not a valid key. So let me do that, run it, and there we go. Cat is not a valid key. So it did the like default that I told it to do here, and it printed not a valid key. So that's kind of the basics of dictionaries. Real simple, but potentially really powerful because they organize data in a really nice way. Let's see here. So the next topic that I wanted to go over are while loops. I mean, again, I'm going to comment out what we have just so it doesn't get in the way. So while loops allows us to execute a block of code multiple times until a certain condition is false. So an example, I'm going to have our I is going to be equal to 1. And the notation, like the syntax for it, is you use the keyword while, and then you do the condition. So I'm going to say while I is less than or equal to 10. And then you do a comma, sorry, colon, not comma. And that's the setting up our while loop. Anything else than under this that's indented, you see how this is automatically indented it here? Anything that's within that indentation is in the while loop. So say I'll just do this. Those 3 lines are in the while loop, but say then I don't indent, and I'm out here. this here is no longer in the while loop. So another, I guess, maybe nice or bad thing, depending on how you look at it at Python, is you don't have to worry about like your curly braces like you do with like C++. You just worry about indentation, but also sometimes in really complex code, sometimes it's really frustrating because it's hard to see what's actually included in what because it's only based on indentation. But that's just how Python works. So let's do an actual example than just gibberish. So while or I, it starts at 1, and while it is less than or equal to 10, I want to output what that I is. I'm going to do something purposely something intentionally here. So all I have right now is just my I is 1, and for as long as the I is less than or equal to 10, I want to output it. Yeah, you know, I'm new to this, and it's like, okay, yeah, I'm good. Looks good. I think it'll work. When we play it, let's hope nothing crashes. There we go. So you see my output here? It just keeps pressing, outputting 1 and 1 and 1 and 1. So it's not doing what we want it to do. We want it to like output it like 1 through 10 maybe, but it's not doing that. It just keeps outputting 1 and 1 and 1. The reason why is because we've accidentally made an infinite loop. So we set our I to 1, and then we print it, but it never turns into something that would make this statement false. Our I is forever staying 1. It's never going to reach a number that's higher than 10, or any number higher than 1 for that matter. So this loop just going to keep going. But be careful with that and make sure that I increment. So I'm going to add 1 to my I, which you can do I is equal to like I plus 1, or a short way to do it is plus equals 1. So our first run of the loop, it's going to print I, which is 1. Then it's going to increment it by 1. It's going to jump back to the front of our while loop. I is now 2. It's still less than or equal to 10. So it's going to output it again. Then increment it. Now I is 3. It checks, is I less than or equal than 10? I is 3. It is less than or equal to 10. So we're going to go back into our loop. And it's going to keep doing that until our I is greater than 10. So kind of show that if we do this, we just print out the value of I, it should print out 1 through 10, but nothing higher than that. So let me run it. And here you go. We start at 1, then we print it out. We add 1 to our I, which is 1, so 1 plus 1 is 2. 2 is less than, or less than 10, so we still keep going. We print out that 2, then add 1 to it, then we get that 3, and then so on and so forth, up until our I is equal to 10. We're going to output that 10, but then we increment it by 1. So I now becomes 11. So it goes up to the front of this loop here, and it sees that I is no longer less than or equal to 10. So it breaks out of that loop. We stop looping. To kind of maybe further iterate on it, I'm going to put outside of my loop, I'm going to put a string done with loop, just so you can show what's actually being looped, and then to show when we're actually out of that loop. I'll write it again. So there you go. We have our 1 through 10, which is all within our while loop. And then once our I is greater than 10, then we break out of that loop and then do whatever's underneath it, which right now we just have that we're done with this loop. And that's basically kind of the basics of while loops, very fundamentals. There's tons of things you can do with it again, but it all depends on what you're trying to do. This is just the bare bones structure of how while loops work in general. Very similar to while loops are, they're called for loops. So again, just so that it doesn't get in the way, I'm going to comment out our while loop here. So for loops are very similar to while loops in that they allow us to iterate through something. So let's do an example. Let's do, like, maybe you want to iterate through every letter in a string. So you use the keyword for, you use some sort of variable. I'm going to call it letter in, And then you do whatever you want to iterate through. In this case, I'm going to say I want to iterate through a string called hamster. You use that colon. And then notice this indentation again. It's indented, meaning that anything that's indented like this will be in my for loop. Versus if I don't indent, now I'm outside of my for loop. So for now, I want to be inside my for loop. So I keep that indentation. And let's say I want to print every letter. Our loop here is going to go through every letter at a time. Meaning our variable here is going to be set to every character per iteration of the loop. Like first, it'll be set to H, then it'll be set to A, then it'll be set to M, so on and so forth. And we just want to print the character that it's accessing, which is being held in this variable that we call letter. It could be anything again. I could call it I if I wanted to. It's just a placeholder for whatever we're going to be grabbing when we're iterating through something. So let me run through it. And there we go. So the first iteration of our for loop is we go through the first letter and then I print out that letter that I went through. Next iteration, it moves on to the next letter. And I just print out what is that letter. And so on and so forth. And it's just going to go through all the letters of this string. Maybe also like I don't want to print out the letters necessarily. Maybe I just want to like, I don't know, print out hi, maybe. Or how many characters are in the string. So for example, let's let it run. Probably be easier to show. So the first iteration, our letter is equal to H. And then it's going to go into our for loop and it's going to output hi. Next iteration, our letter is going to be set to A. And then we just have it outputting hi again. And it's going to keep iterating through each character in the string, printing out hi each iteration until it reaches the end. Hopefully that helps. Again, like to maybe, you don't have to just print like what you're accessing, that iteration. Let's also show you what it is actually accessing each iteration. First the H, then the A, M, S, T, E, R. This kind of basic one, I'll definitely go over more because for loops, personally to me, are a little bit more tricky than while loops, at least in Python, because they're I guess the furthest like from other for loops in other languages. Like if you've learned JavaScript, very similar, if not pretty much like the same. But like C++, this is like bizarre for loops. So let's see, let's go back to our friends. We'll do a friends list again. So I have Alex, I have David. Let's say I have another friend named Connor. And maybe I want to go through this list. I'm going to do for, and then any variable that I want, whatever I want to name it, I'm going to name it friend. In, and then I say what I want to iterate through. I want to iterate through my friends list. Again, notice the indentation. I'm inside my for loop and I tell it what to do for each iteration that it's going through this list. So it's first going to go through Alex, then David, and then Connor. So say I want to print the element that it currently is accessing. So I'm going to do my variable here that I named friend. So it's going to go through each item in our list and each iteration, our variable here, friend, it's going to be set through whatever that value that we're currently looking at. So like the first iteration, friend is going to be equal to Alex. Next loop, friend here is going to be equal to David. And then the next one, friend is going to be equal to Connor. So let me output to show you. And there we go. We still have our hamster there, but they went through, it did Alex first, then I went through David, and then I went through Connor. And I don't have to necessarily actually use the values in the list. Maybe I like only want something to iterate 3 times for some reason or whatever. I have 3 items in this list, so I could totally do this too. I can print like, I don't know, I could do my hide again. But there's 3 items in my list, so it's only going to iterate 3 times. So it's going to output this hi 3 times. all again depends on up to the user what you want to do, but this is just how to iterate over a list in general. You just say for some sort of variable, I can even name it like value if I wanted to, in friends. So it's gonna go over your first value, and then your second value, then your third value, and however long until you reach the end of your list. Put this back. So it's two examples of for loops. Say though you don't want to like iterate over a string, or you don't want to iterate over a list, you just want to go from like a range of numbers. You can totally do that using a method called range. It's a keyword called range. So how we're going to do it is I'm going to say for, and it's any variable that you want to call it. Like if you're used to like C++, you do like maybe it starts at like int is equal to I is equal to 0 up until some value, and then you I plus plus at the end. I'll do kind of like the equivalent here, I guess. I could say for I in, then you use this range keyword. So my range, I'm going to put 10. And I'm just gonna, I first got to make our for do something, then I'll explain how this range is working. I use that colon, and I just want to print out what our number is, which I is keeping track of what our number is. It's going to start at 0, and it's going to keep going up until this range 10. So I'm just going to print whatever that value is. Again, just so I don't confuse ourselves with this, I'm just going to comment this out real quick. Print this. And there we go. Our I starts at 0. And then it's increased by 1 each loop up until 9. But I may be thinking, well, why is it only 9? I said to do it up to 10. When it comes to range for Python, the number here is excluded. So meaning if you want to do a range up to 10, you can't put 10, you have to put 11. Meaning it's going to go from 0 to 10. It's going to stop at 11. Like those, you can see if I put a 10 there, it's going to start at 0, but then it's going to stop at 9. It's not going to do 10. So it's a little weird, but that's just how the range works in Python. So that's just from like 0 to 9. If you don't say what the starting range is for your range, it's just going to start at 0 and go up to whatever your highest value is. But maybe you want to start at a certain value. I'm just going to say for I in, I'm going to do my range still. The first I that I put in can be a starting number. So I'm going to say, I'm going to start when my I is equal to 3. And I want to go until I is 9. So maybe intuitively you might think, oh, I put a 9 here. Remember range, the upper bound is not included. So it's not going to include that 9 there. It's going to go to 8. So if I want it to go to 9, I have to put in 10. Colon, and then I'm just going to print whatever our current I value is. So I guess also not to confuse ourselves, just comment this out. And there we go. Our I, it starts at 3, and then each increment of, or sorry, not increment, each iteration of our for loop here, each time we're looping, it increases that I by 1. And it's going to keep doing that for as long as, or up until range from 3 to 9. Basically, you can almost think, yeah, we're going to start at 3, and for as long as I is less than 10, basically, is another way to kind of look at it. Here, I'm just outputting the values, but say you want to actually do something within that loop, like a simple example is I want to output high a certain number of times. In this case, maybe I want to, oops, sorry. Maybe I want to output it like 4 times or something like that. So the way to do that is I want to output like 4 times. So it's going to, again, I starts at index 0, then it's going to be set to 1, then 2, then 3, and it's going to stop at 4. So if I want something it to loop 4 times specifically, I do it like this. For I, again, this could be anything. I could put num, whatever I want to call it. And then within this range, as long as it's less than 4, it's going to do what's in this loop. In this case, I have it because I starts from 0. It's going to output our loop it's going to loop 4 times, outputting high 4 times. There's two more examples that I kind of want to go over. Is maybe you want to like access each item like in a list at once, like a different way to do it. Maybe like you don't know like the link, or no, sorry, yeah. I'm trying to think of how to word this. Let's see here. I guess because we technically have before, we've kind of done it iterating through all the items in a list, but there's another way we can do it that I'll show that can kind of sometimes be useful. So for, and then we're going to have some value to keep track of our iteration. I'm going to call it index in. So I'm going to do a range. So our index is going to start from 0 and it's going to go up to some certain value. What I want to do is I want it to go through from 0 to the number of friends we have in our friends list here. So I'm going to do the length of our friends list. So this length, it will tell us how many elements do we have in our list, friends. We have 3 elements. So our index will go from 0 up until 2, because this technically here, because we have 3 items in our list, this is technically a 3. But again, remember for range, it's non-inclusive. So it's going to go from 0, 1, and then 2. And once it hits 3, it's not going to do it. So we're going to go through from I is equal to 0 up into however many items we have in our list. And then maybe I want to like print the friend at that index. So I'm going to access our friends list. And I want to access whatever's at that index. So I need to make sure I have my friends list not commented out, so Python knows what it is. So to reiterate, our index is going to start from 0. It's going to go up until the length of our friend list, which is 3. So it's going to go from 0, 1, 2. And it's going to stop at 3. It's not going to include 3. And what we're going to do in this loop is we want to access something that's in our friends loop. So we call our friends, sorry, not friends loop, friends list. We call our friends list here. And what we want to access is whatever is at this index. So maybe I'll output index as well. So it's kind of maybe helps to visualize what's actually going on here. So we're going to ignore our highs here. Our index, it starts at 0. And then I access whatever is at index equals 0, which is the first item in our list, which is Alex. That's one loop. And then our index is incremented by 1. Now it becomes 1. But 1 is still within the range of the length of our list here. So it's going to keep going. It's going to output our index, which is now 1. It's going to output what's at our first index, which is David. And then it's going to loop again. It's going to increment our index by 1. So index is now equal to 2. It checks, is this index within this range? We have 3 items in our list here. So again, this is like range. Technically, you look at it as 3. Well, 2 is still included in that. So it's going to loop again. It's going to output that index, which is currently 2. And it's going to output what's at that index in our friends list, which happens to be Connor. Connor's at index 2. Then the next loop, index is going to be incremented one more time. This time it's going to be 3, but 3 is not in this range anymore. Again, remember, because we have 3 items, this range is technically 3, but 3 is not included, meaning it's only going to go from 0 to 2. Once it hits 3, it's going to stop. So hopefully that makes sense. I know for it to get a little bit more complicated. So give me one moment. Either computer fell asleep. One moment. There we go. Okay. So the last thing about loops I want to cover is we went over dictionaries. And so we didn't really do much when it comes to like the functionalities of what you can do with dictionaries. Let's say you want to go through the keys maybe and then like find all the values. I'm going to use our dictionary here. I'm going to comment out all this stuff so it doesn't get in the way. And say maybe I want to go through each key and then output its value. I can use a for loop to do that. So for, and then you use some sort of variable that's going to be set to each value in this dictionary here per iteration. So first it'll be set to January, then it'll be set to February, then it'll be set to March. So I'm going to say for item, let's call item, again, it could be anything. I'm going to iterate through my month's conversion, but specifically I want to go through the keys. So I'm going to do dot keys. So I should actually probably, I think I explained it a tiny bit wrong. So this item will actually be, I'm going through the keys. So it'll first be this Jan, then it'll be this February, then it will be this March. So I'm basically just gonna iterate through these keys within my month conversions dictionary here. And I can do whatever I want. Maybe, again, just to show you how many times it's looping, maybe I want to like print hi for each item, aka I guess you say each key in my dictionary. So I'm gonna run it. It should output 3 times because the first iteration, our item here is set to the key Jan. The second iteration, our item is set to the key February, or just Feb, I should say. And then the last iteration, our item is set to the key March, or Mar, sorry. Let's say you wanted to like maybe print the actual like value. You totally can. I think I'll first print the key itself, which is just our item. And then I'm going to print the value at that key. So I do that is I call my month conversions. And I use that key to access the item. So our item, again, is the current key that we're looking at. And I want to access what's at that index in our month conversion. So for example, if the key that we're looking at right now is this January, it's going to get whatever value is at that key January. Sorry, JAN, which should be the full January. So let me run through that to show how it's working. So the first thing I do is I print just my item, and the things I'm iterating through are my keys of my dictionary. So at first, outputs that first key, Jan, but then I want to get that item actually held by that key, the value of that key, which I did here. I use that key to access the value at within the month conversion, which is that full January. Then the next loop, our item is now going to be set to the next key, which is that Feb. And I also then print out what is the value of that key, which is the full February. And then it does the same thing for March. So that's looping through a dictionary. Again, could be very useful if you're using a dictionary, just great data structure for so many different things. This is how you can actually iterate through the entire thing. So thankfully, if you don't like for loops, that's all I have for loops. The next I want to get into is, I'd say probably argumentatively a lot easier. For loops are a little bit tricky. They do take some practice in Python. But the next one is really easy. They are if, elif, and else statements. So conditional stuff. I'm just going to say if statements. So say you want to have your code make like some sort of decision based on some criteria. And so like you want to have it where if some criteria is true, your code does something. Or if it's not true, it doesn't do something. So let's have 2 Booleans here. We'll have is male is equal to true, and then you'll have is tall is equal to true. Let's say depending on if they're male, it does certain things. If they're male and tall, it does certain things. If they're only tall but not male, it does certain things, or neither. They're not male or they're not tall. We wanted it to do different things. you use a keyword called if, and then the condition. If this condition is true, then it'll do what's in the if statement. So in this case, if is male is true, then I want to print out you, oops, forgot my parentheses here, you are a male. And I'll just run it through to show you. Is male is true, so it printed out you're a male. But say I'm not a male, so is male is set to false. Then I run my code and see what happens. It didn't do anything, which makes sense because now is male is false, and so it doesn't trigger this if statement. It does. I don't do what I have within this if statement because is male is not true. I'm gonna set it back to true though. Let's see here. Let's do, if you have like multiple conditions, you have like if they're this or they're this or they're this, that kind of like thinking, you use elif. If you've done other programming, it's the equivalent of else if. Python just kind of shortens it down to just elif. So I'm going to say, let's see, else if they are male or they're tall. This is a great time to bring up, you can use keywords like this, like or and within Python. You just type literally just what it is, lowercase for or and lowercase for and. So this is going to do something if is male is true or is tall is true. Both don't have to be true. If only one of them is true, then it's going to do what's in this elif statement. So in this case, I'm going to print you are male or you are tall. Then we can have another condition. Maybe you have to be both. Say elif or else if they are male and they're tall, we're going to print you are male and you are tall. And then finally, maybe we have no other conditions. We just want to have some sort of like default thing we want it to do. You use the keyword else. And so if none of these conditions are true, then by default, it's going to do whatever is in this else. So I'm just going to print you are either not male or not both. Because we have if they are male and tall, and we have if they're male or tall. But if they're not male or they're not both, this else will catch that. It'll output this. So let's see, we have both the true. Which makes sense, it does the first one because we are male. That is true, so it's going to do this. So what if we're not male? Put the false. But I'm going to keep is tall to true. I'm going to run it. In this case, is male is false, but is tall is true. So this elif statement is triggered because we have is that or there. It's okay that we're not male because is tall is true. So it outputs this, you are male or you are tall. And then I kind of, if I want to do both, I kind of have to get rid of this first one because if they are male, it's always going to print out this regardless if they're tall or not. So for now, I'm just going to comment this out real quick. I don't need to. So now say now they're both true. Let me run it. Oh, I'm sorry. Yeah, same order of operations because it still sees that both says that's true and that's true. It still triggers that or. So let me just comment stuff out. I guess that's a good example of how Python works is it does it line by line. So in this case, I started with if is male. Well, I have is male and is tall is true. So technically it satisfies all three of these, but if is male comes first. So it just outputs you are male. But say maybe I have this one, if you're male and tall first. I'm just going to move it to the front. Or just up higher. And make sure that's an elif. And this one, since the first one, is an if. Now, because this is first, if is male is true and is tall is true, it'll go into this statement first, check this, and then decide is it going to do what this if statement is saying or not. In this case, we are male and we are tall. So this if statement is triggered and it outputs this. Now let's say both are false. I'll run it. And then we get the output, you're either not male or not both, which makes sense. We are not tall and we're not male. We're not male and we're not male or we're not tall. So this else statement is triggered. And we just put how to say you are either not male or not both. Hopefully that makes sense. That's messing with Booleans, but you can also do it with numbers, like if things are greater than, less than, or anything like that. So I'll show an example here. Say we have one number is equal to 5, and then we have num2 is equal to 6, maybe. I don't know. Let's do 10. I'm also going to comment this out just so it doesn't get in the way. So we can say, we can use conditional operators like greater than, less than, greater than or equal to, less than or equal to. Any combination of, or not any combination, any of those if we want. So like I say, maybe if num1 is greater than num2, I want to do something. So I'm going to print exactly that. Num1 is greater than num2. Maybe I have another condition like else, if, or elif. Num1 is less than num2. So I'm going to print that out. I'm going to say num1 is less than num2. And I'll do one more. Elif num1 is greater than or equal to num2. And we can print. I'll just say num1 is greater than or equal to num2. And of course, if I want to, I can have a default else that does something if none of these conditions are true, but it's not necessary. Maybe say I just want to make some comparisons, and then it should just move on if none of these like are triggered. Then I can exclude the else. Otherwise, if you want to have it do like something by default, that's totally fine. For now, I'm not going to have it do anything like by default if none of these are true. So let me run it. So what it did is we have our two numbers here, num1, num2. It does this first if statement first. It says if num is greater than num2. Well, 5 is not greater than 10, so it skips this, moves on to the next condition. Else if num1 is less than num2. That is true. 5 is less than 10, so it's going to print this, which we said num1 is less than num2. Say though, we have now both are equal to maybe like 10. We run it. Now we see the first condition it tested is 10 greater than 10? It is not. The next condition is 10 less than 10? It is not. But the final one, 10 is less than or equal to, in this case it's, it's equal to num2. So 10 is less than or equal to 10. So it outputs what we told it to output in that case, which is num1 is greater than or equal to num2. So that's the basics of if statements. You have things like you use and, or, if things are true, not true, comparisons, all that type of stuff. If you want to do like stuff's equal, you could totally do that too. You could say elif, num1 is, if you want to say if it's exactly like equal to, you could do like num2. So that if like num1 is 10 is equal to num2, which say like a 10, then it does something. You could also do that. But that's it for now for if statements. I know it's almost 3. Almost done. I just want to go over functions real quick. Just do two really simple functions. Because so far we've just been doing like everything, and what this is called is the global space. We just started just typing stuff into our Python program. It's like it's not included in anything, it's not sectioned out, it's just we just started typing it. But say you wanted to keep like a collection of code in a certain area, you can use something called functions. They're specifically useful if you want to have like your code, a certain part of it do something very specific. Then functions are great for that. So let's see, maybe, I don't know, something very simple. I want to call a function that's all it's going to do is say hi. So to create a function, you use the keyword def. And the name of that function, I'm going to name it say hi, open and close parentheses, and then that colon. Again, notice this indentation. Whatever is indented underneath this, our function header here, function name I should say, it's going to be in that function. And all I'm going to have this function do is just going to say hi. It's going to print hi. That's all it's going to do. So right now, if I were to run my code, let it do its thing. Oops. It didn't do anything. Yeah, we have the code here, but it's a function. It's just, it's code ready to go. We have it do something. But to actually use that function, we have to actually call it. So I'm going to be out here in the global space. I'm going to do it underneath. I'm outside of my function, just kind of this global space. I'm going to call my function. And the way I do it is you just use the name. I'm going to do say hi, and then the open close parentheses. It's going to call that function and do whatever this function is supposed to do. So run my code. I call this function on this line 196. It jumps up to this function and then does whatever the function says to do, which we just have it say hi. Says the like basic bare bones, super simple one. I want to do one more that's a tiny bit more complicated, but not that much. Maybe if you want to have like a function that handles like multiplication. So I'm going to make a function using def, and then I'm going to call it multiply. So functions have these things called parameters. If they're optional or not. Right now for my say hi, I have nothing in these open close parentheses, but maybe I want to give a function values to work with. You give them in these open close parentheses, and they're called parameters. So multiply, you want to multiply two numbers. So I'm going to give it some kind of first number and some kind of second number. These parameters can be named anything. It's just letting this function know, hey, I'm going to pass you a value. I'm going to pass you a second value. And then within this let's see, this function here, you want to multiply those two. So I'll do like num1 times num2. But say we want our function to actually like return a value, like we're going to call it, give it values, and then it should give us something back. You're going to use a keyword called return. So what this function is going to do, you're giving it two values, num1, num2. It's going to multiply them together, and then it's going to give you back whatever that product is. So I'll do an example. I'm now outside my function. I'm in the global space. I say I want to find a product. I don't want to have to like manually like num1 times num2. Like what if I have to do that like a ton of times? It'd be really annoying to have to manually do it. So that's why I can use my function for it. It's instead of manually typing like num1, num2, and then doing it again for all these other different numbers, I can just call my function. I'm going to say product is going to be equal to whatever my multiply function gives us. So I'm going to call again that multiply function. But again, we have to give it two values. We told our function, hey, we're going to give you num1 and we're going to give you num2. Now we have to actually give it values. So maybe you want to multiply like 4 and 5. So give it 4 and give it 5. And so when we call this function, it's going to pass in this 4 as num1. It's going to pass in this 5 as num2. It's going to multiply them together, return that value, and our product here is going to be set to whatever value our multiply function just found. For that, I'm going to just print out our little product here. Oops. So I'll do that. So we still have our say hi, it's just kind of hanging out there. But we told our multiply function we want to multiply 4 or we want to multiply 5. It does that multiplication and then it returns the product 20. And that product, now that we just found 20, is held in a variable we call product. And what's great about functions, you can keep using it over and over again. Maybe I want to have like, I don't know, a second product. I'll say like product 2 equal to, I will just call that function again and pass in 2 other values. Maybe like I want to multiply like 5 times 5 or something like that. So I'm going to print product 2. There we go, there's our 25. It first did the, the 4 times 5, and now I just called it again, but this time I gave it a 5 and I gave it a 5. Multiply it together and found 25. So that's the basics of functions. Again, they could be super complex or super simple, just very, very nice kind of way to organize your code and kind of segment things off. So you have certain like blocks that do certain things, certain parts of code that are responsible for different things. Just really helps you organize stuff. And I think that's about it. I did have an example, but I know it is already 3. So I think I'll end it off here. Do any of you guys have any questions? Say if you don't, I just want to say thank you so much for stopping by. Hopefully this was helpful, learning a bit of Python. So I know for a lot of classes here, they don't really use it, but it's still a really helpful and useful language. And I believe its popularity has kind of been in the rise recently. So now at least you can say you have some Python under your belt. So I hope you have a great day. Bye.